students, so in today's class we will discuss the very important concept, that is the effect of substituent on the acidity of carboxylic acid. Okay, so on the basis of this concept they will ask the so many questions in JEE and NEET exam. So we just go through this concept. What is the effect of substituent? Substituent means it may be electron withdrawing group, it may be electron donating groups. So what effect when this electron withdrawing group is attached to the any acid, and what effect going on when the any electron donating group is attached to the any acid. Okay, just check it. So you know that electron withdrawing groups, so if any acid containing the electronic withdrawing groups, what happens student, then acid strength increases or decreases? Obviously when electron withdrawing group is attached to the any acidic compounds, the acidic strength what increases, because they can withdraw the electron and they can loosen the bond. Okay, and the H plus ion is easily removed. Okay, so here electron withdrawing group increases the acidity of carboxylic acid. Okay, and they stabilize the conjugated base through the delocalization of the negative charge by inductive or resonance effect. So here inductive and resonance effects will occurs when we will see this phenomena. Okay, resonance structure you know already, and inductive effect also already discussed. So electron donating group, you know that electron donating groups, they can decreases the acidity by destabilizing the conjugated base. Just see here I am given one general structure. EWG is nothing but what? Electron withdrawing group. So here I am drawing. This is a carboxylate COO minus, just it is a stabilizing the carboxylate anion. So electron withdrawing group stabilizes the carboxylate anion and strengthen the acid. So they can stabilize the carboxylate anion, they can increase the acidity of the any compounds. Electron withdrawing group, they can release the electron, they can withdraw the electron to itself. Okay, and see another here, electron donating group, we can see this electron releasing group also. So the electron donating groups, so they can donate the electrons and electron density going to be increased. So they can destabilize the carboxylate anion. You remember that electron donating groups, where they can donate the electron density going to be increased, and electron EDG you can denote it as EDG, electron donating group. They can destabilize the carboxylate anions and become the acids. Okay students, now I am see some few example. So those who are asking in JEE exam, how they are asking the questions on the basis of this concept, just see here. First example I am given here. So it is example, just benzene ring containing the carboxylic group COH group, means it is benzoic acid, and below it attached with the OCH3, means it is a methoxy group. Okay, so in the second one, so it is a benzoic acid benzene containing only COH group. And third example, benzene containing COH group benzoic acid, and at para position NO2 group is there. So students, tell me in that first how we can check it which is a strong acid. Okay, so they are asking like this: order of acidic strength of carboxylic acid. Write the correct acidic order of above examples. So they are given these three examples. So which is a stronger acid? So here they are given. Just check it. In third example, NO2 group is there. NO2 group is nothing but it is a nitro group, it is an electron withdrawing groups. You know that what happened, this can withdraw the electrons from benzene ring. Okay, and then what happened, acidic strength going to be increased. Already we discussed electron withdrawing group can increases the acidity. Okay, so here first example, this OCH3 group. Okay, so this is a methoxy group, they can donate the electron. Okay students, they can donate the electrons towards the benzene ring, and the density of electron going to be increased. So it is what, as compared to this is a less acidic. Then see the third one example, this is a benzoic acid. So in this case, which is the correct order, which is a more strong acid? In that C is a strong acid, then C is greater than B, then A, because it is electron releasing group or electron donating group, they can decreases the acidity, you know that. Then first one, which one? C, option C. Option C is greater than B, B is greater than A. So A coming at last because electron donating group is attached here. So already we discussed electron donating group, they can decreases the acidic strength. Now clear students? here electron donating group is there. So whenever they are given an example, you just check it whether electron donating group is attached or electron withdrawing group it is attached. So if electron withdrawing group is attached here, then you can check it is a first. Suppose same example they are given here, but I am given in different way. So if electron withdrawing groups, so one more NO2 group is attached, then which will come first? Then this will come. So because two electron withdrawing group is there. Okay students, on the basis of number of electron withdrawing group also we can check it. If one more NO2 group is attached, then it is very strong. Now clear? So 3 NO2 group means they can withdraw the electron is very fast and acidic strength increases. Now clear students? Number of electron withdrawing group is more, the acidic strength also more. Okay, all of you clear this concept, electron withdrawing group and electron donating groups. See one more example. So here I am given CF3COH. This is a trifluoroacetic acid. Okay. Then NO2 group, CH2 and carboxylic group COH. NO2, CH2, COH. This one, and this is CH3COH acetic acid. This one. So you just check it where electron withdrawing group is attached. So NO2 is electron withdrawing group. Yes. Then this trifluoroacetic acid. This is also a strong electron withdrawing group. You know that. So trifluoroacetic acid is a very strong electron because 3 fluorine are there. So all 3 sides they can withdraw the electrons. Then NO2 group, and then here acetic acid. It is an electron donating group. It is come at last. Means how acidic strength, which is the first? Obviously this trifluoroacetic acid is more stronger acid than this. It is only one NO2 group is attached, but here 3 fluorine is attached. It is a strong electron withdrawing group. This is also electron withdrawing group, but here number of electron group is very more high and number of strength also increases. And this one like this means first is greater than second is greater than third. So which is a weak acid? So last one, acetic acid is a weak acid. Now clear students, on the basis of this we can solve the question like this. In JEE they are asking so many times on the basis of this concept. Okay, so one more example, just check it. So here I am given some example. Here first example A, this is a formic acid HCOOH, then acetic acid CH3COH, then this benzoic acid. Okay students, so in this case which is a strong acid, so you know that CH3 is electron releasing group, or you can say it is electron donating group. So here it is also, but in case of formic acid, so it is a very strong. Okay, A is strong, then C will come, and last which one? B. Okay, so because electron donating group is there, but most of the time what we are doing, so due to this benzene ring, due to the resonance, first we can write this. Okay, this is wrong. So here also resonance occurs, you know that. H, C double bond O like this, H, C double bond O, H. So this double bond will shift like this, no pair of electrons are there. It also shows the resonance. Okay, so that's why it is a very strong acid. Which one? Formic acid come first, then benzoic acid, and last one acetic acid. Okay, CH3 is electron donating group. So I hope everybody understand this concept. So you can solve the other example also. So most of the competitive exam they are asking the questions on the basis of this order of acidic strength. Okay students, so in next class we will discuss the another chemical reaction. So thank you so much for watching this video. Okay.